In the early months of the Pacific War, American pilots believed they held a reasonable advantage in the skies. They had trained extensively, their aircraft were proven in combat, and their confidence was unshakable. But there was an aircraft about which little was known, a sleek silhouette that appeared in a whisper and vanished after leaving behind American fighters that seemed frozen in place. They called it the Zero, and very soon it began destroying squadron after squadron, as if it were an unstoppable combat machine. American command was confused. Had a nation they believed to be technologically backward built the world's best fighter? The answer came on an unexpected day, when a Zero fell intact on a remote island. Engineers, mechanics, and test pilots couldn't believe what they were seeing. That discovery would change the war, but first, it would reveal an uncomfortable truth. They had completely underestimated Japan. This is the story of the exact moment when the United States understood what it was facing in the Pacific skies. December 7th, 1941, the day everything changed. Pearl Harbor shattered American illusions of invulnerability. But beyond the immediate devastation of the naval base, something else emerged from the smoke and chaos. Something that would haunt American airmen for months to come. Among the Japanese aircraft that struck that Sunday morning, one type stood out to the few who managed to observe it closely. A nimble, graceful fighter that seemed to dance through anti-aircraft fire. The reports that followed were fragmentary, often dismissed as the fog of war. Survivors spoke of aircraft that could outmaneuver anything they had seen before. But in the chaos of defeat, these observations were filed away, noted but not fully comprehended. The United States was focused on counting its losses, not analyzing the weapons that had inflicted them. The first encounters, something doesn't add up. In the weeks following Pearl Harbor, as Japanese forces swept across the Pacific, American pilots began encountering this mysterious fighter in increasing numbers. The Philippines, Wake Island, the Dutch East Indies, everywhere the rising sun advanced, reports filtered back that defied conventional understanding. Lieutenant Edward "Butch" O'Hare, who would later become America's first flying ace of the war, described an early encounter. It turned inside us like we were standing still. We'd been told Japanese aircraft were inferior copies of Western designs. That wasn't what we saw up there. The Grumman F-45 Wildcat, America's frontline carrier fighter, was a sturdy, reliable aircraft. American pilots trusted it. But against this Japanese fighter, the Wildcat seemed hopelessly outmatched in maneuverability. The Curtiss P-40 Warhawk, defending the Philippines and Burma, fared no better. Combat reports began accumulating at Naval Intelligence and Army Air Forces headquarters. The pattern was undeniable and deeply troubling. Pilots described an aircraft that could outturn any American fighter in sustained combat, climb faster than seemed physically possible, maintain energy in ways that violated their understanding of aerial combat, operate at ranges that suggested either impossible fuel capacity or forward bases no one had discovered. The growing mystery. Intelligence officers faced a puzzle. Before the war, Western estimates of Japanese aviation had been dismissive, sometimes contemptuous. The conventional wisdom held that Japan, while capable of copying Western designs, lacked the industrial sophistication and engineering creativity to produce truly advanced aircraft. Their optical equipment was assumed inferior. Their engines were thought to be underpowered copies of foreign designs. These assumptions had seemed reasonable. Japan's economy, while growing, remained smaller than America's. Its aviation industry was younger, less established.
The few Japanese aircraft that Western observers had seen before the war, trainers, reconnaissance planes, had not impressed them. But the reports from the Pacific told a different story. And with each passing week, as more American pilots encountered this aircraft and fewer returned to describe the experience, the urgency of understanding this fighter grew. The Americans didn't even know its proper designation. Some called it the Navy Type Zero. Others simply called it the Zero, a reference to the year 2600 in the Japanese calendar, 1940 in the Western calendar, when the aircraft had entered service. But names mattered less than understanding. What made this aircraft so formidable? The Philippines. Lessons written in blood. The Philippines campaign provided the first sustained aerial combat between American and Japanese forces. It also provided the first clear demonstration of the Zero's capabilities and American vulnerabilities. The P-40s of the Far East Air Force were flown by experienced, well-trained pilots. Many had been spoiling for a fight, confident in their abilities and their aircraft. That confidence evaporated within days. The Zero's performance in the Philippines was devastating. It could engage American fighters at will, choosing when to fight and when to disengage. American pilots found that their standard tactics, developed fighting German aircraft in Europe or in theoretical exercises, simply didn't work. Captain Colin Kelly became one of the first American heroes of the war when his B-17 was credited with sinking a Japanese battleship, a claim later proven exaggerated. But Kelly's bomber was subsequently attacked by Zeros, and he was killed when his damaged aircraft crashed. The incident highlighted another disturbing truth. The Zero could catch and destroy even the formidable flying fortress. Wake Island. The pattern confirmed. Wake Island's defense became an early symbol of American resistance. The tiny garrison's Marine fighters, also F-4F Wildcats, fought with extraordinary courage. Major Paul Putnam's VMF 211 Squadron achieved some success by refusing to dogfight with the Zeros, instead using diving attacks and the Wildcats' superior diving speed and structural strength. But even this modified tactic couldn't overcome the fundamental mismatch. The Marines at Wake fought brilliantly with what they had, but what they had was insufficient. The island fell, and with it, more evidence accumulated. The Zero was not just another fighter. It was something fundamentally different. The intelligence gap. By early 1942, American intelligence was frantically trying to piece together information about the Zero from multiple sources. Combat reports from surviving pilots, reconnaissance photographs, often blurry and taken from poor angles, second-hand accounts from British and Dutch forces who had also encountered the aircraft, technical documents captured in early raids, most incomplete or damaged. What emerged was a frightening profile. The aircraft appeared to be powered by a radial engine of unknown specification. Its wingspan was notably long, suggesting either high-altitude capability or emphasis on maneuverability. Its armament included cannons, 20-millimeter weapons that could destroy American aircraft with brief bursts, something uncommon in early war fighters. But the most disturbing characteristic was its performance envelope. The Zero seemed to violate fundamental principles of aircraft design. Maximum maneuverability and maximum speed were typically trade-offs. Heavy armament meant reduced performance. Long range meant carrying more fuel, which meant more weight, which meant reduced agility.
The Zero seemed to ignore these constraints. It was highly maneuverable and fast enough to catch American fighters. It carried heavy armament and could execute sustained high-G maneuvers. It had extraordinary range and could still fight effectively at the end of long missions. Something didn't add up. And until American engineers could examine an actual Zero, that something would remain a deadly mystery. The question no one wanted to ask. In the quiet offices of naval intelligence and in the Pentagon's corridors, an uncomfortable question began to circulate, usually in whispers, sometimes in carefully worded memos. Had America fundamentally miscalculated Japanese technical capabilities? The question was more than academic. If Japan could produce an aircraft this advanced, what else might they have? Were American assumptions about Japanese industry, Japanese engineering, even Japanese strategic thinking, all fatally flawed? Admiral Ernest King, Commander-in-Chief of the U.S. Fleet, demanded answers. General Henry Hap Arnold, commanding the Army Air Forces, wanted data, hard, verifiable data, not speculation. But data required something they didn't have, an intact Zero to study. Pilots who had fought the Zero and survived offered their advice. Don't dogfight. Use speed, not turning ability. Attack from above, dive through, and escape before the Zero can respond. The Thatch Weave, a defensive maneuver developed by Lieutenant Commander John S. Thatch, showed promise by allowing wildcats to cover each other, preventing Zeros from exploiting their turning advantage. But these were tactical adaptations, ways to survive and occasionally win despite flying inferior aircraft. What American forces needed was strategic understanding. How was this aircraft built? What were its actual specifications? Most importantly, what were its weaknesses? Because every aircraft has weaknesses. The Germans had learned this about the Spitfire. The British had learned it about the Messerschmitt. Engineering is always about trade-offs, compromises, priorities. The Zero had to have made compromises somewhere. But where? That answer would come from an unexpected place, in the most remote corner of America's new Pacific War. The Aleutian Campaign, a forgotten front. While most American attention focused on the South Pacific, on Guadalcanal, on New Guinea, on the Solomon Islands, a smaller, stranger campaign unfolded in the fog-shrouded Aleutian Islands of Alaska. This remote chain of volcanic islands, stretching toward Japan across the North Pacific, seemed an unlikely place for significant combat. Yet in June 1942, as part of the Midway Operation, Japan occupied the islands of Otu and Kiska. It was partially a diversion, partially an attempt to establish a defensive perimeter in the northern Pacific. For both sides, the Aleutians would prove to be a brutal, unglamorous campaign fought in some of the worst weather on Earth. The Japanese forces in the Aleutians included fighter units equipped with Zeros. American forces would respond with P-40s, P-38s, and whatever else could be scraped together for this secondary front. The battles that followed were small-scale, often obscured by weather, and generally ignored by a press focused on more dramatic theaters. But it was here,
in this forgotten corner of the war, that fortune would intervene in the most unexpected way. June 4, 1942. The accident at Akutan. Petty Officer First Class Tadayoshi Koga was an experienced Zero pilot, a veteran of combat operations who had survived the dangerous early months of the war. On June 4, 1942, the same day as the decisive Battle of Midway, though Koga couldn't have known that, he participated in an attack on the American base at Dutch Harbor in the Aleutians. During the engagement, Koga Zero was hit. The damage wasn't catastrophic, no fire, no structural failure, but it was serious enough. Most likely, a bullet had severed his oil return line. The Nakajima Sake engine that powered the Zero was already streaming oil, and Koga knew he wouldn't make it back to his carrier. Standard procedure called for crash landing and destroying the aircraft to prevent capture. Koga followed the first part of that procedure. He spotted what appeared to be a relatively flat meadow on uninhabited Akutan Island and brought his Zero in for an emergency landing. What Koga couldn't see, what the grass concealed, was that his meadow was actually a muskeg, a boggy wetland common in the Aleutians. When his Zero touched down, the soft ground grabbed the aircraft. The impact was violent. Koga, following standard practice, hadn't fastened his seatbelt for the emergency landing, common procedure to allow quick escape from a potentially burning aircraft. The sudden deceleration threw him forward. His head struck the aircraft's gun sight. He was killed instantly. The Zero, meanwhile, had nosed over but remained largely intact. It sat there, inverted, on a remote island, one of the most valuable intelligence prizes of the Pacific War, waiting to be discovered. 5 weeks of waiting. The Zero sat on Akutan Island for nearly 5 weeks before anyone found it. Japanese forces, unable to return to the area and unaware that Koga's aircraft had survived relatively intact, wrote off the loss. American forces, focused on Dutch Harbor and the immediate tactical situation, didn't immediately search the surrounding islands. The delay was fortunate. It gave the Zero time to settle, to stabilize in its inverted position. Heavy rain would have turned the site into an impassable bog. Strong winds might have damaged control surfaces. But for those crucial weeks, the aircraft waited, largely undisturbed except by the island's seabirds and foxes. The discovery, when it came, was almost accidental. A Navy patrol, conducting a routine sweep of the islands, spotted the aircraft. Initial reports were cautious. Japanese aircraft crashed all the time, and most were damaged beyond value. But as the patrol approached, they realized what they had found. The Zero was nearly intact. Its engine was present. The cockpit, though damaged by the inverted landing, still contained instruments. The wings were largely undamaged. Most incredibly, the aircraft appeared recoverable. Get that airplane. The message that reached naval intelligence in Washington was electric. Intact Zero, Akutan Island, recoverable condition. Within hours, recovery plans were in motion. This wasn't just another crashed aircraft to catalog and file. This was the answer to 6 months of desperate questions. Every hour that Zero remained in the Aleutians was an hour it might be destroyed by weather, discovered and destroyed by Japanese forces, or rendered unserviceable by the harsh environment. A recovery team was assembled under Lieutenant William N. Bill Tice, a naval aviator with engineering experience. The team included mechanics, structural specialists, and protection forces. They would travel to Akutan, assess the Zero, and, somehow, get it back to the United States. The challenges were substantial. Akutan had no real port facilities. The terrain was difficult. The weather was, even in summer, unpredictable and often dangerous. And the Zero itself, while intact, was inverted and partially buried in soft ground. The team arrived in late June. What they found exceeded their best hopes. Yes, the aircraft was inverted. Yes, the propeller was damaged. Yes, there was combat damage and impact damage. But the airframe was sound. The engine could be removed. The instruments were readable. This was salvageable. The recovery operation. The process of recovering the Zero was methodical and carefully documented. Every step was photographed. Every component was cataloged. The team worked with the awareness that they were handling something precious, a window into Japanese aeronautical engineering. First, they had to right the aircraft. Using block and tackle, carefully supporting the wings and fuselage, they managed to flip the Zero upright without causing major structural damage. The process took days. The weather didn't cooperate. The ground remained treacherous. But slowly, carefully, the Zero returned to its proper orientation. Next came disassembly. The wings were removed at their attachment points, a process that revealed the elegant simplicity of Japanese engineering. The engine was carefully extracted and crated. The cockpit instruments were removed individually, each one holding insights into Japanese avionics and tactical thinking. The components were transported to the coast, loaded onto vessels, and shipped south. By late July, the Zero, in pieces but complete, arrived at Naval Air Station North Island in San Diego, California. The real analysis could begin. First impressions, shock and revelation. When the Zero was reassembled at North Island, the team of engineers and test pilots who gathered to examine it experienced a collective shock of recognition. Everything the combat reports had described was suddenly, tangibly real. But more than that, they could now see how it was real. The first thing that struck everyone was the aircraft's weight, or rather, the lack of it. Engineers hefted components that should have been heavy and found them remarkably light. The construction was unlike anything in American practice. Where American designers used thick aluminum sheets and heavy internal structures, the Japanese had used thin skins and minimal internal framework. Commander Frederick Trapnell, one of the Navy's most experienced test pilots, would later describe his first impression. When I walked around that airplane, my first thought was that we'd been fighting something built more like a glider than a fighter. My second thought was that whoever designed this understood aerodynamics better than we'd given them credit for. The Zero's construction revealed a design philosophy radically different from American practice. Weight reduction as primary design goal. Every component had been optimized for minimum weight. Skin thickness was minimal, in some places barely thicker than heavy paper. There was no armor protection for the pilot. The fuel tanks were unprotected, no self-sealing compounds that American aircraft carried as standard. Even the instrument panel was made of lightweight materials that would have been considered unacceptable in American designs. Structural elegance. Despite the weight savings, the airframe was brilliantly designed. The wing spars were masterpieces of stressed skin construction. The designers had used every trick of aeronautical engineering to maintain strength while shedding weight. The result was an airframe that was lighter than American equivalents, but still structurally sound for its intended purpose. Armament layout.
The Zero carried two 7.7mm machine guns in the nose, synchronized to fire through the propeller arc, and two 20mm cannons in the wings. This was heavier armament than most fighters of 1941 to 1942 carried. The cannons were particularly impressive, slow firing but devastating when they connected. Engine installation. The Nakajima Sakai engine was a revelation. It wasn't the crude copy of Western designs that pre-war intelligence had suggested. It was a sophisticated, well-engineered power plant that produced 940 horsepower, not exceptional by American standards, but adequate. The key was what the engine had to move. With the Zero's light weight, that 940 horsepower provided remarkable performance. Range capabilities. As the engineers calculated fuel capacity and consumption rates, they reached a startling conclusion. The Zero's combat radius was approximately 1,200 miles. American fighters of the period had combat radii of 200 to 400 miles. The Japanese had achieved nearly triple the range of comparable American aircraft. How? By making the aircraft lighter, requiring less fuel to travel the same distance, by using fuel-efficient engine settings, and by giving the Zero enormous internal fuel capacity. 150 gallons compared to the Wildcat's 144 gallons, but with much better efficiency per gallon consumed.
The test flights. Theory becomes reality. Reassembling the Zero took several weeks. The propeller had been damaged beyond repair in the crash, so a roughly equivalent American propeller was fitted, not ideal for performance testing, but adequate for basic flight evaluation. Some instruments had to be replaced with American equivalents. But the essential aircraft, airframe, engine, control systems, was pure Mitsubishi A6M2, the variant known as the Zero Sen Model 21. In September 1942, Lieutenant Commander Eddie R. Sanders climbed into the cockpit for the first American test flight of a Zero. The aircraft started smoothly. Japanese engine reliability was apparently as good as their performance. Sanders taxied, checked controls, and advanced the throttle for takeoff. What followed was documented in detailed flight test reports that still exist in Navy archives. Sanders' official evaluation, stripped of emotion, nevertheless conveyed shock. Aircraft displays exceptional maneuverability in all axes. Rate of roll exceeds expectations. Turn radius at combat speeds is substantially tighter than any American fighter. Climb rate is excellent. Pilot visibility is superior to American designs. Control response is light and immediate. In less formal conversations, Sanders and the other test pilots were more direct. If you try to turn with this thing, you're dead. It doesn't matter how good a pilot you are. The Zero will turn inside you, line up a shot, and that's it. Subsequent test flights mapped the Zero's performance envelope in detail. Maximum speed, approximately 330 miles per hour at 14,000 feet. Good, but not exceptional. The Wildcat could manage about 320 miles per hour, and newer American fighters like the P-38 Lightning were faster. Speed wasn't the Zero's advantage. Rate of climb, around 3,000 feet per minute initially, better than most American fighters. The Zero could climb to 20,000 feet in about 7.5 minutes, performance that would remain competitive throughout the war. Maneuverability. This was where the Zero dominated. Its turn rate was approximately 15 degrees per second at combat speeds, substantially better than any American fighter. The Zero could complete a 360-degree turn in roughly 24 seconds at 175 miles per hour. The Wildcat needed about 32 seconds. That 8-second difference was the margin between victory and death in aerial combat. Diving performance. Here, crucially, the Zero showed weakness. The light construction that gave it phenomenal maneuverability became a liability in high-speed dives. The aircraft developed control flutter above 350 miles per hour. The ailerons, the control surfaces that govern roll, became heavy and unresponsive at high speeds. Pilots reported that diving the Zero felt like fighting the aircraft. This was the first concrete weakness American pilots could exploit. The technical reports, understanding the trade-offs. As engineers compiled their findings, a complete picture emerged of the Zero's design philosophy and its implications. The Japanese designers had made a radical choice: sacrifice protection and diving performance to maximize maneuverability, range, and climb rate. This wasn't simply accepting trade-offs, this was embracing an entirely different combat philosophy. American design philosophy emphasized pilot protection, robust construction, and the ability to absorb battle damage. American fighters had armor plate behind the pilot's seat. They had self-sealing fuel tanks that could take hits without catching fire. They were built heavily enough to survive punishment and bring their pilots home. The Zero had none of this. A burst of machine gun fire that might damage but not destroy a Wildcat could catastrophically damage a Zero. The unprotected fuel tanks meant that incendiary rounds could set the aircraft ablaze. The lack of pilot armor meant that even glancing hits could wound or kill the pilot. But in exchange for these vulnerabilities, the Zero had become the most maneuverable fighter in the world, and one with unprecedented range. Japanese doctrine emphasized pilot skill over aircraft protection. The best protection, Japanese designers believed, was not getting hit, which required superior maneuverability. The aggressive focus on offensive combat, on getting behind the enemy rather than surviving enemy attacks, drove every design decision. It was a coherent philosophy. It had produced a formidable aircraft. And now, finally, American forces understood both its strengths and its vulnerabilities.
Tactical intelligence, the fight back. The technical analysis of the Akutan Zero was immediately classified and distributed to command staffs across the Pacific. But equally important were the tactical bulletins that went to frontline fighter units. These bulletins were direct, practical, and potentially life-saving. Do not dogfight the Zero. This was emphasized repeatedly. American fighters could not outturn a Zero in sustained combat. Attempting to do so was suicide. Use speed and altitude. American fighters, particularly newer types like the F-4U Corsair and F-6H Hellcat, then in development, were faster in level flight and especially in dives. The tactic that emerged was called boom and zoom. Dive from altitude, make a high-speed attack, and escape in a dive or high-speed climb before the Zero could bring its turning ability to bear. Attack from above when possible. Altitude gave American fighters energy, the ability to convert height into speed. A diving attack was fast enough that the Zero's maneuverability advantage became irrelevant. Exploit the Zero's diving limitations. If trapped in combat with a Zero, the correct response was to push into a high-speed dive. The Zero couldn't follow effectively. American fighters could dive away, extend, reset, and re-engage on better terms. Fight in pairs. The tack-weave and similar tactics allowed American fighters to cover each other, preventing Zeros from exploiting isolated targets. Aim for the aircraft, not just the pilot.
The Zero's vulnerability to fire damage meant that hits anywhere on the aircraft could be devastating. The unprotected fuel tanks were particularly vulnerable. These tactical insights, derived from the Akutan Zero, were battle-tested through late 1942 into 1943. They worked. American losses to Zeros decreased. The kill ratio improved. Pilots who followed the new doctrine survived and gained experience. The Zero was still dangerous. It would remain dangerous throughout the war, but it was no longer an invincible mystery.
The strategic impact, redesigning American air power. The analysis of the Akutan Zero didn't just change tactics, it fundamentally altered American aircraft development. Engineers at Grumman, Chance Vought, Lockheed, and other manufacturers received detailed reports on the Zero's capabilities and vulnerabilities. These reports influenced every fighter design that followed. The most immediate beneficiary was the Grumman F-6F Hellcat, already in development when the Zero was captured. Grumman engineers had designed the Hellcat as a Wildcat replacement, but the Zero analysis allowed them to optimize their design specifically to counter the Japanese fighter. The Hellcat that emerged incorporated every lesson from the Akutan Zero. Raw power. The Hellcat used a massive Pratt & Whitney R2800 engine, producing 2,000 horsepower, more than double the Zero's output. This gave the Hellcat superior speed, especially in climbs and dives. Robust construction. The Hellcat retained heavy armor protection, self-sealing fuel tanks, and rugged construction. It could absorb tremendous battle damage and continue fighting. Diving performance. The Hellcat's heavy, strong construction allowed it to dive at high speeds without control flutter. It could outdive any Japanese fighter. Adequate maneuverability. While not as maneuverable as the Zero, the Hellcat was agile enough for effective combat when flown using proper tactics. The result was a fighter that could engage Zeros on favorable terms. Hellcat pilots could choose when and how to fight, using speed and power to dictate engagement conditions. The Hellcat entered service in January 1943 and would ultimately achieve a kill ratio of 19-1 against Japanese aircraft, the best of any American fighter. The F-4U Corsair, entering service around the same time, similarly benefited from Zero analysis. Even faster than the Hellcat and with exceptional high-altitude performance, the Corsair could dominate Zeros by fighting at high speeds and high altitudes where the Zero's advantages evaporated.
Training revolution. Knowledge as a weapon. The Akutan Zero's greatest contribution might have been educationally. Before its capture, American pilot training included general combat tactics, but nothing specific about fighting Japanese aircraft. After the analysis of the Zero, specialized training programs emerged. The Zero itself, repaired and flyable, became a training tool. Selected squadrons preparing for Pacific deployment received demonstrations. American test pilots flew mock combat against the Zero, showing trainees exactly how it moved, what it could do, and crucially, what it couldn't do. These demonstrations were revelatory. Pilots who had heard about the Zero's capabilities but never seen them were stunned by its turning performance. But they also saw its weaknesses demonstrated. The flutter in high-speed dives, the heavy ailerons, the vulnerability to even light damage. Training doctrine evolved to emphasize energy management, maintaining speed and altitude advantage. Patience, refusing to be drawn into turning fights. Teamwork, mutual support to prevent isolation. Aggressive diving attacks followed by immediate disengagement. Gunnery training also shifted. Pilots learned to take shots during brief, high-speed passes rather than maneuvering for sustained tracking. They learned to aim for the aircraft's center mass, knowing the unprotected fuel tanks made any hit potentially catastrophic.
Survival rates for newly deployed pilots improved dramatically. The difference between pilots trained before and after the Akutan Zero analysis was measurable in combat losses. Knowledge, it turned out, was as valuable as raw performance. Perhaps the most important change was psychological. The discovery and analysis of the Zero forced American military leadership to confront their pre-war assumptions about Japanese technical capabilities. Before the war, American intelligence assessments of Japanese industry had been dismissive, sometimes bordering on racist. Japanese products were viewed as cheap copies. Japanese engineering was considered imitative rather than innovative. These assumptions had seemed reasonable based on pre-war information, but had proven catastrophically wrong. The Zero demonstrated that Japan possessed genuine engineering excellence. The aircraft's design was not only sophisticated, but in some ways more advanced than contemporary Western fighters. Japanese engineers had made different choices, optimized for different values, but their work showed creativity, skill, and deep understanding of aeronautical principles. This realization rippled through American military thinking. If Japan could produce an aircraft like the Zero, what else might American intelligence have misjudged? The complacency that had characterized some pre-war planning evaporated. Japanese capabilities in submarines, in torpedoes, in tactics, in training were reassessed with newfound respect. This didn't mean overestimating Japanese capabilities, but it did mean taking them seriously. The casual dismissiveness was gone, replaced by professional recognition that the enemy was skilled, determined, and technologically capable. The Zero's decline, from dominance to obsolescence. The Akutan Zero's analysis came at a crucial moment. By late 1942, American industrial production was accelerating. New aircraft designs were entering service. Pilot training was producing thousands of new aviators. The Pacific War was shifting from desperate defense to methodical counteroffensive. The Zero, meanwhile, remained largely unchanged. Japanese industry, strained by the demands of a vast war across Asia and the Pacific, struggled to develop replacements. The Zero's successor, the A6M offered only marginal improvements. More advanced fighters, like the N1K2J Shiden Kai, or George, and the J2M Raiden, or Jack, appeared too late and in too few numbers to matter. American pilots, now flying Hellcats, Corsairs, P-38 Lightnings, and later the P-51 Mustang, held decisive advantages. The new American fighters were faster, more powerful, and more heavily armed than their predecessors. Their pilots were trained specifically to counter Japanese tactics, and American numbers grew while Japanese numbers dwindled. Trained pilots lost in combat couldn't be replaced. By 1944, the Zero had become obsolete, outmatched by newer American fighters. It remained dangerous. A skilled Zero pilot could still threaten unwary Americans, but the systematic advantage had reversed. American fighters now dominated the Pacific skies, and the Zero, once the most feared aircraft in the theater, had become another target. The aircraft's vulnerabilities, so thoroughly documented by the Akutan Zero analysis, were exploited ruthlessly. Unprotected fuel tanks meant Zeros burst into flame easily. Lack of pilot armor made even glancing hits potentially fatal. Light construction meant that damage that would cripple but not destroy American fighters could break apart the Zero. The Akutan Zero's fate. The original Akutan Zero, the aircraft that had provided such crucial intelligence, had a short but illustrious American career. After its initial evaluation at North Island, it was transferred to other facilities for additional testing.
Engineers at Wright Field examined its engine. Structural experts at various facilities studied its construction techniques. On February 16, 1945, the Akutan Zero was being ferried to another test facility when the engine failed. The pilot, attempting an emergency landing, crashed. The aircraft was destroyed and the pilot was seriously injured. After 3 years of service to American intelligence, the Zero that had survived its original crash in the Aleutians was finally lost. But by then, its work was complete. The information it had provided had been integrated into American tactics, training, and aircraft design. Thousands of American pilots had benefited from its lessons. The aircraft itself was gone, but its impact on the Pacific War was permanent. Lessons beyond aviation: the cost of underestimation. The story of the Akutan Zero transcends aviation history. It stands as a case study in the dangers of underestimating an adversary based on preconceptions rather than evidence. American pre-war intelligence had failed to accurately assess Japanese capabilities. This failure stemmed from multiple sources: limited access to Japanese military development, cultural assumptions about Japanese technological abilities, and perhaps a degree of complacency born from America's own industrial strength. The cost of this failure was measured in lives. In the early months of the Pacific War, American pilots died fighting an enemy they didn't understand, flying aircraft that were mismatched to the threat, using tactics that didn't work. The learning curve was steep and paid for in blood. The Akutan Zero shortened that learning curve. It didn't end the war or change its ultimate outcome. American industrial capacity would have eventually overwhelmed Japan regardless. But it saved lives. Every pilot who learned to fight the Zero effectively, every aircraft designer who incorporated lessons from its analysis, every commander who adapted tactics based on its capabilities, they all benefited from one Japanese pilot's fatal landing on a remote Aleutian island. The broader intelligence war. The Akutan Zero was the most dramatic example of technical intelligence in the Pacific War, but it wasn't the only one. Both sides continuously studied captured equipment, analyzed wreckage, interrogated prisoners, and compiled combat reports. Japan captured American aircraft and equipment throughout the war, though less systematically than the Americans. Japanese engineers examined downed B-17s, captured P-40s, and retrieved crashed bombers. They learned about American construction techniques, armor schemes, and armament. But Japan's ability to translate this intelligence into production was limited. Japanese industry, stretched thin by multiple conflicts and increasingly cut off from raw materials by American submarines, couldn't rapidly incorporate new designs. The Zero remained in production largely because there was no capacity to replace it. America, by contrast, could translate intelligence into action. The industrial base existed to rapidly modify existing designs and develop new ones. The training infrastructure could disseminate new tactics throughout the combat forces. The logistical network could deliver improved aircraft to frontline units within months. The Akutan Zero thus represented not just an intelligence coup, but a demonstration of American systematic advantages. The ability to gather information, analyze it thoroughly, distribute findings widely, and implement changes rapidly across a vast military organization. The Mitsubishi A6M Zero became, in retrospect, a symbol of multiple historical themes: Japanese technical achievement, The Zero represented genuine Japanese engineering excellence. Whatever its ultimate obsolescence, it was a remarkable aircraft for its time, demonstrating sophistication and innovation. The perils of strategic surprise. Pearl Harbor and the Zero's dominance both showed how much damage an underestimated enemy could inflict. American complacency before the war had real costs. The value of intelligence. The Akutan Zero demonstrated how a single intelligence windfall could shift the tactical balance of an entire theater. Industrial warfare. The Zero story illustrated how wars between industrial powers are ultimately decided by production capacity, not just by the elegance of individual weapons. The Zero was arguably better designed than its early American opponents, but American industry produced better aircraft in overwhelming numbers. The human element. Behind every technical specification was human decision-making. Japanese designers chose maneuverability over protection. American designers made different choices. Neither was objectively right. They reflected different philosophies, different tactical doctrines, different values about what mattered most in air combat. Conclusion. The day the mystery ended. The capture of the Akutan Zero didn't happen in a single dramatic moment, but across weeks and months. The crash, the discovery, the recovery, the analysis, the dissemination of findings, the adaptation of tactics, the influence on aircraft design. But taken together, these events represented a turning point. Before the Akutan Zero, American forces were fighting a mysterious, seemingly invincible opponent. Combat reports described an aircraft that defied understanding. Pilots died without comprehending what killed them. Engineers struggled to design counters to a threat they couldn't fully analyze. After the Akutan Zero, the mystery was gone. American forces understood exactly what they faced. A brilliant but vulnerable aircraft, highly capable within its performance envelope, but exploitable outside it. They knew how to fight it, what to avoid, how to survive, and how to win. The psychological impact was as important as the tactical information. American pilots, previously intimidated by the Zero's reputation, gained confidence. They learned that the Zero, while dangerous, was not invincible. It had weaknesses. Those weaknesses could be exploited. Victory was possible. In war, understanding your enemy is fundamental. The Akutan Zero provided that understanding. It revealed the truth about Japanese capabilities, not the dismissive pre-war assumptions, not the panic-driven overestimations of the early defeats, but the actual complex reality. That reality was sobering. Japan had produced an excellent fighter and fielded it with skilled pilots, but it was also manageable. The Zero had weaknesses. American industry could produce counters, and properly trained pilots could win. June 4th, 1942, the day Tadayoshi Koga crashed on Akutan Island, was one of the most consequential days in aviation history. Koga couldn't have known that his routine emergency landing would provide his enemies with the information they needed to defeat his nation's air forces. But that's the nature of war. Small moments, chance events, random circumstances can have consequences far beyond their immediate context. One crashed aircraft, one fortunate discovery, one thorough analysis, and suddenly the course of an entire air campaign shifts. The Akutan Zero taught America to respect its enemy, understand its capabilities, and adapt accordingly. Those lessons, learned from a single captured aircraft, helped turn the tide of the Pacific Air War. The Zero would remain dangerous throughout the conflict, but it would never again be a mystery. And in war, removing the mystery from the enemy's greatest weapon is halfway to victory.